Do you know Rocket League? This was one of my all-time favorite games, but I decided to stop to stay mentally healthy. But that's not the point of today. You can customize your car using decals. There are even animated ones, and it's exactly what we are going to try to reproduce. Hello, in this video we will discover the scary world of shaders to be able to create very advanced and cool effects. We will learn the followings. What is a shader? How to create a custom shader material with Three.js? And how to use Leva to debug and change parameters on the fly. What is a shader? A shader is a program that runs on the GPU. We will discover two types of them. The vertex shader, its role is to position each vertex of a geometry, and the fragment shader, to define the color of each pixel of that geometry. Let's take a plane. It contains 4 vertices. For each vertex, the fragment shader will be called with many inputs. The mesh position, rotation, scale, same for the camera with additional information, such as the field of view and the lighting. Then the program outputs the final position of this 3D information into a 2D screen. This information is then passed on to the fragment shader that will be called for each pixel inside that geometry. For example, you have the X and Y coordinates of the vertices. If you take this pixel, the fragment shader will be called with X equals 0.5 and Y equals 0. If you take this one, the fragment shader will be called with X equal 1 and Y equal 1. And based on those data, the fragment shader will output the color of this very pixel. Don't worry, we will only work with the fragment shader today. Before creating our own shader, let me show you when you want to think about using a custom shader. Water, cell shading, like in Zelda Wind Waker, the shrinking zone in Fortnite or any battle royale game, wall hack in Counter-Strike, and of course, Rocket League decals. Shaders are everywhere. I'm sorry, because now you will see the word differently. Once you clone the repository, run yarn and yarn dev. We have a scene already set up with the Cybertruck model ready to be modified and a scene animation. I won't cover how to build this scene because if you follow the other React Refiber tutorials I made, you already have all the required pieces of knowledge to achieve the same. I got the model from Hashikamu on Sketchfab. I reworked it a bit. I duplicated the body to create a slightly bigger mesh on top of it to show you how to work with the shader transparency. Let's create a shader. We've already been using shaders without knowing it when we use different types of materials. A basic material only displayed the mesh form without lighting. You can see the car had the same red everywhere, while the standard material is more three-dimensional. If we add an opacity and set our basic material to transparent, we colorize our car while keeping the lighting and reflections from the real car material below. Now let's create our shader material. Let's copy the default implementation from React 3 Drei documentation, rename it and remove the input parameters for the moment. The Three.js documentation can help us understand the parameters. The first one is an object containing the uniforms, data we can pass to the shader. The second is the vertex shader string, and the third is the fragment shader string. Let's simplify the fragment shader code. We will get back to it later. The extend method allows us to use the material declaratively using camel case syntax like the other Three.js primitives. And let's set our test shader material instead of the basic one. Now if we reload, we can see it's going from blue to purple. Let's have a look at what our fragment does. It set the fragment color RGBA to a vector 4. It contains the red, green, blue and opacity information. VUV is the data we got from the vertex shader. To make it simpler, let's switch to black and white for the moment. Let's declare a float named strength equals to the y coordinate. create a vector 3 composed of the strands. What it does is it sets all values of the vector to the strands. We now have shades from black to white as R, G and B are always equal. We can use the X instead of the Y on the strands. It will change orientation of our gradient. Instead of coding our shaders inside the JavaScript file, let's create a shaders folder. Inside we create a stripes.fragment.glsl and stripes.vertex.glsl. This is the file extension for OpenGL shading language, the language used to compile shaders. Let's copy our existing code into them. To have the syntax coloration, search for shader language support in your Visual Studio extension. Now we import the shader files. Rename the shader to stripes shader material, replace the strings with the imports and use the stripes shader material. Our material now uses the shader files. If you are not using the starter pack, you need to install Vite plugin GLSL and add the plugin in your Vite configuration file. To build our stripes, we will need to apply some functions to our UV coordinates. Let's start by adding step 0.5 on the Y parameter. What it does is if the Y value is below 0.5, strength will be equal to 0, and if it's over, it will be equal to 1. We don't have a gradient anymore, but instead we have the left completely white and the right part completely black. To make stripes from it, we need to repeat this effect over the car. Let's multiply our UV coordinates by 10 to make it 10 times. But because we want values between 0 and 1, we use mod for modulo of 1. We now have stripes. We can switch to the y-axis and set the multiplier to 42 for a better look. We are losing the metallic reflection because we don't handle it and our material cover entirely the real one. The last parameter is the transparency. Let's use min, strength and 0.5. That way we will only have values between 0 when it's black, so entirely transparent, and 0.5 when it's white, so half transparent. It doesn't work. We need to add the transparent prop on our material. Now we can see our shader and the reflection of the material below. Instead of our hard-coded alpha and multiplier, let's pass parameter to our shaders. It's called uniforms. That's why it's good to prefix them with a U. In the shader, declare uMultiplier and uAlpha float uniforms and replace our values. It's still working correctly. To change them on the fly, instead of building a complex UI, we can add Leva library. Adding it globally next to our app, we can now use everywhere use controls. If the first parameter is a string, it will create a folder. Let's name it stripes. Inside add alpha and the multiplier. To pass the values to our material, we can just add them as props. It's now easier to adjust values. Let's add colors to our stripes. We create uniforms with 3 colors. We add color A and B to Leva. It can automatically detect when it's a color and display a color picker. And let's pass it to our material. A color is a vec3 of red, green and blue value. We declare our uniforms and we create a mix color for our fragment. The mix functions return a value between the first and second parameters based on the third parameter. As we only display either a color or transparency, we can only see our yellow color. Let's use our multiplied y coordinate instead of the strength. We now have a gradient from the yellow to the red. Let's use step and mod to have one stripe on 2 of each color. Now we want to animate our stripes. To do so, we add a new uniform named uTime. We create a reference to our material, and in the useFrame function, we set the uniform to our material with the elapsed time from our scene. In the shader, we can bind it into a float uniform. Let's increase our y coordinates with the time and use modulo to keep values between 0 and 1. Our stripes are now moving correctly. We can simplify the color formula as our stripes move to build another effect. Perfect! Let's build a second shader named disk shader material. We command the stripe shader for now. We create the GLSL files and let's only keep the multiplier formula for now. I found an interesting pattern to use in another tutorial. I will give you the resources to learn how to create yours at the end of the video. It's just mathematical formulas and a lot of fun. Most of the time you will find ready-to-use shaders, but it's good to understand how they work and how to create them yourself. Let's add the time to animate it. We can add the scene function to make the animation go back and forth. We can fine-tune the parameters to make it look bigger. And even animate the color of each shape over time. Excellent! Now let's render one shader or the other based on the one we will select using Leva. By default we won't have one, so let's add a condition we have a reference before assigning the time uniform. And let's add the shader options to Leva. It renders a drop-down. We can also add a button to restart the opening animation of our experience. Voila, your getting started shader journey is now over. Wrapping up, I simplified some aspects and we didn't cover the vertex shader. I highly recommend you those resources to understand better and to practice the book of shaders. It's the Bible to understand it in depth. Three.js Journey, there is a whole chapter with 5 lessons about it and it's very well explained. The study of shaders with React Refiber article from Maxim Heckel. Of course, you can find the links in the description below. Thank you for watching, I hope you enjoyed this video. If you did, please hit the like button as it really helps this content be visible to more fellow developers. Tell me in the comments what you are trying to build with Three.js and I will build the tutorials to help you, but you need to subscribe to know when they are released. Oh, and if you want to learn more and sharpen your React Refiber skills, watch this video tutorial.